जिससे अपने अंदर के भी ऐब दिखाई देते हैं। ऐब का मतलब होता है शॉर्ट कमिंग या फिर किसी तरीके का दुर्गुण, जिससे अपने अंदर के भी ऐब दिखाई देते हैं, वैसा भी हमने एक अपना चश्मा बनवा रखा है। डॉक्टर नवाज देवबंदी का ये शेर और हमारे सेशन की शुरुआत। इट्स नॉट दैट ओनली वी हैव अ शॉर्ट कमिंग्स, a manufacturing processes can also have. The way manufacturing processes are performed or executed can also have a shortcomings, and many times these shortcomings result into the defects. And almost all the time defects are not desirable because they produce a poor quality component. Today in this session we are going to discuss about the defects which come into the components which are produced by metal casting process. So now let us look at the first set of defects. The first defect that we are going to discuss is a blowhole. So blowhole is a defect which looks like a, which is usually round into the shape and which is present just below the surface of a casting. Now if we have, let's say, very small holes which are present below the surface of a casting, then that particular defect is called as a pinhole. If we have a blowhole which is open to atmosphere, then that will be called as a scar. And when we have a scar which is partially covered by, let's say, a metallic surface, then it is called as a blister. If we have a small very tiny holes which are present uniformly throughout the casting, then that defect is called as a porosity. So when we talk about these 5 defects, blowholes, pinholes, scar, blister and porosity, they come into the casting because of a single reason, and the reason is a low permeability of a molding sand or a low permeability of a mold. So we know that when the solidification process takes place, when the liquid gets converted into the solid, the liquid metal has dissolved many gases, and during the process of a solidification, these gases wants to get out of a liquid metal, but because of the low permeability of a molding sand, those gases are not able to leave liquid metal, and when the liquid gets converted into the solid, they also remain in a solid. But we also know that the solids have a very low solubility of a gases or air, and due to that they are visible in form of any of the defect when the component when the solidification is completed and when the component is produced by a casting process. So the reason is low permeability of a molding sand. Now, is there any way to avoid this defect? Yes, there is definitely a way. By increasing the permeability of a molding sand, we can avoid these defects. Now the question is that how can we increase the permeability? So by providing the ventilations, that is the first way. The second way is that we need to use large size spherical shaped silica sand particles. By using that, we will be able to increase the the permeability. And the third reason, the third method of increasing permeability can be reduction into the compacting or a reduction into the ramming force. So by these 3 methods, we will be able to improve the permeability of a molding sand, and we will be able to avoid this type of a defects. Now when we talk about second type of a second set of defects, the first one is a misrun, and the second is called as a cold shut. So what is a misrun? Whenever we are pouring a liquid metal into the mold cavity, the liquid metal is not able to fill the complete mold. It reaches at a one point, and then because of lack of fluidity, it has lost the degree of a superheat. It reaches at a one point, and then the liquid metal solidifies. And so let's say this is the last point till which a liquid metal has to be filled, but liquid metal lost, or I would say miss the run by this much distance, and so this defect is called as a misrun. Now let us talk about the cold shut. Let's say there are 2 streams of a liquid metal coming from both the sides, from here and here, and when they have to fuse together actually, but because of lack of fluidity or because of a less degree of a superheat, they are not able to fuse together, and so they will form a defect like this. So here the one stream has solidified, and at this point the another stream has solidified, and this particular defect is called as a cold shut. The misrun and cold shut both of them have a same reason. The reason is the lack of fluidity. The lack of fluidity comes because of when we do not give enough degree of a superheating, and as we know that a degree of a superheating is nothing but a difference between the pouring temperature and a melting point at temperature. So when the sufficient amount of a degree of a superheating is not given, it will have a less fluidity, and this type of defects will come. In order to avoid that, we need to increase fluidity. When we will increase the fluidity, the degree of a superheat is should be increased, and when the degree of a superheat will increase, the viscosity will increase, and with increase in a viscosity, liquid metal will flow freely into the mold, and such kind of defects will be avoided, right? Okay. Now let us talk about third set of defects. Let us assume that this is an ingate, and through which the liquid metal is entering into the mold cavity. But the mold is a loose sand mold, or the molding sand does not have a sufficient strength, or the mold does not have a sufficient strength. So when liquid metal enters, what happens is that some of the sand which was not having sufficient amount of a strength will be displaced from its original place. And when the liquid metal is going to displace the sand, definitely the sand will go along with the liquid metal into the mold cavity. At the same time, the liquid metal is going to take the place of a sand, and at that time this particular type of a shape will be produced in a metal casting. It should be actually a straight surface, but because of the displacement of a sand, which can also be called as a mold erosion, this particular shape is produced into the casting, which is called as a wash. It can also be called as a sand wash. Now, a defect which is very similar to the wash when it happens onto the top surface, which means when the particles of a liquid metal enters into the top surface of the mold, the defect like a scab is produced. And when you see all this random shapes that you are seeing, it is nothing but a molding sand. So when the liquid metal, the top surface of a liquid metal, goes like this into the mold surface, and when the sand particles are left below that, at that time a defect like a scab is produced. One more defect is that when the liquid metal has a high fluidity, and when there are, let's say, a small cracks which are present on the mold surface, so what will happen? Because it has a high fluidity, it will try to get into those cracks which are present into the mold surface, and at that time, after solidification, naturally we should have actually a straight what I can say, the surface, a flat surface we should have. But we won't get a flat surface. Instead of that, we will see this type of a metallic projections coming out of the flat surface, and that type of a defect is called as a penetration. Penetration, scab and wash, the reason behind them is insufficient strength of a mold or insufficient strength of a molding sand. So if we can increase the strength of a mold, in that case we will be able to avoid the defects like a wash, a scab and a penetration. Now let us discuss about a defect which is called as a hot tear. It is also called as a hot crack. So towards the end of a solidification, a liquid metal, or let's say a metal, because towards the end of a solidification it is, so there is a partial solid, partial liquid, the metal wants to shrink in a certain way, and if due to some of the geometric reasons, let's say the metal is not allowed to shrink in a certain way, then it is going to develop a residual stresses within it. And when the residual stresses are going to cross a certain limit, and as we know that stress is nothing but a one type of energy, so when the residual stresses will increase, the certain type of energy is going to increase, and that energy actually makes the crack into the component. It tears, it tears the casting, and that's why it is called as a hot tear or a hot crack. The other reason can be, there can be a differential cooling rates. So there is a certain section of a casting where the cooling is taking place very fast. There is a certain section when the cooling is taking place slowly. So due to this differential cooling rates, again, the residual stresses can form. Now near the very sharp corners, when you learn when you learn the a design of a pattern, or let's say design of a mold or design of a getting system, we are said, and especially in machine design also you must have learned this, that we should be avoiding the sharp corners, because nearer the sharp corners you will see that the residual stresses are formed. So because of the presence of a residual stresses near the sharp corners, crack can also form. So these are the several reasons why the hot tear or hot cracking takes place, right? And if we talk about, let's say, a next defect, then the next defect is called as a shrinkage pipe, or if it is present into the, let's say if we talk about into the component, it is not open to atmosphere, but into the component if it is present, it is called as a shrinkage cavity. Now shrinkage pipe and shrinkage cavity comes into the component because of we are not able to compensate the liquid shrinkage which takes place during the process of solidification. So when we do not provide a riser, at that time the shrinkage pipe or shrinkage cavity comes into the component. There are two ways by which we can avoid these two defects. The one is by providing a riser, and at several critical sections, if we can provide chills which are going to enhance the rate of solidification of those critical sections, by providing the chills also we will be able to avoid these defects. So after discussing several defects, let us discuss a few more defects. When the cope and drag, both of them are not aligned with each other, and if, let's say, a pouring takes place, then there is going to be a shift which has taken place between the cope and drag, cope being the upper part of a mold, drag being the lower part of a mold. So in that case, one defect comes, and that defect is called as a mold shift. Mold shift can be avoided by using the alignment pins. So if we use alignment pins, you might have seen at the, when they make the mold, when they place a cope over drag, at that time they insert two pins on both the sides, and they make sure that the proper alignment has taken place. So those alignment pins are used to avoid the defect like a mold shift. Sometimes when let's say we want to produce a hole into the center of a casting, but the core has shifted from its original position, in that case, the hole will also shift, and that particular defect is called as a core shift. So mold shift and core shift are the two defects which happens because of the shifting of a cope and drag or a shifting of a core. And the last defect that we are going to discuss is a dross inclusion and a sand inclusion. We know that the liquid metal has a huge amount of energy, and it wants to react with the oxygen, it wants to react with the atmosphere, and it wants to form the oxide layers. When the oxide layer is formed into the liquid metal, before pouring it, we try to remove the oxide layer. An oxide layer is also called the dross. Now, if we are not able to, let's say, remove oxide layer, or let's say we are not able to remove all the oxides which are present into the liquid metal, then they will remain into the component which is produced by a metal casting process in form of a dross, and that is called as a dross inclusion. And as I earlier explained, sometimes when the molds do not have a sufficient amount of a strength, when the liquid metal passes through the, let's say, components of a gating system, it also takes some of the sand particles with it, and sand particles later on becomes the part of a component. And that particular defect is called as a sand inclusion. And so these are the several defects which are experienced into the metal casting process. So thank you very much for joining this session. If you have not understood something, please feel free to write to me. And towards the end, इश्क है तो इजहार कर, इश्क है तो इजहार कर. अगर अच्छा लगे वीडियो तो लाइक कर, शेयर कर, सब्सक्राइब कर. थैंक यू.